So now we want to find the least common multiple between two numbers. So suppose we have two numbers. The LCM is the smallest multiple that is common to both, which is why we call it the least common multiple. How do we find this? Well, as always, first we come up with the prime factorizations. Next, you pick or select the greatest exponents among the two factorizations for every factor and multiply the selections. An easier way to remember this: greatest common divisor, smallest exponent. Least common multiple, largest exponent. So it's the opposite. Greatest, least exponent, least, greatest exponent. So it's just opposite. And it's the same thing, you know, multiple, division. They're opposites of each other too. Let's see. Let's take as an example 18 and 24. Well, 18, we could come up with a prime factorization. Two and 9, 3 and 3, 24, 2, 12, 2, 6. 6 times 2 is 12. 2, 3. 3 times 2 is 6, and that's the farthest we could go. So 18, I can write it as 2 times 3 times 3, 3 squared. And 24 is 2 times 3 times 3. So the multiple, the smallest multiple that you can come up between the two is 2 cubed multiplied by 3 squared. I'm picking the bigger power or exponent. If they are equal, we can pick the value that is common to both exponents. So I end up getting 8 times 9, which is 72. So the multiple that you can find in common between the two is 72. One may ask, well, that doesn't make any sense. Well, it certainly does. So if you look at the multiplication table 18 times 1 is 18. 18 times 2, 36. 18 times 3, 54. 18 times 4, 72. 18 times 5, 90. 18 times 6, 108. Let me stop right there. 24 times 1, 24. 24 times 2, 48. 24 times 3, 72. 24 times 4, 96. Well, I kind of hit what I wanted. So if you look at this, 18 is not a multiple to both. 36 is not a multiple that appears in both. Neither does 55 or 48, but 72 appears in both cases. So since 72 appears in both 18, the multiplication table of 18 and the multiplication table of 24, then the least common multiple has to be 72. Now, you can easily argue, well, there could be one way down below for 18 and 24. Could there be another common multiple? Absolutely. There could be another, or there are definitely more multiples after this that would be common to both. However, they're all bigger than 72. We are looking for the least common multiple. Another way to look at this is the given numbers 18 and 24, both of them will divide the least common multiple. So the easier way to remember or check if your answer is correct is to take the answer and divide by the given two numbers. If the given two numbers divide the answer that you have, then you have the correct least common multiple. Do keep in mind, I could keep on going and find more common multiples, but I don't care about those because I want the smallest one. So the moment I hit 72, I stop. So 25, the smallest prime would be 5. That's the best I could do. 70, 5, 14. 14 is divisible by 2. So 2 and 7. 7 is prime. We can leave it as is. So 25 is 5 times 5. 5 squared. 70 is 5 times 2 times 7. Now we've got to pick the greatest power. So 5 squared. When it comes to the common multiple, we can't ditch the 2 and the 7. The reason being we're not looking for the common divisor. We're looking for the smallest multiple that we can come up with. So another way to remember this is to rewrite the ones that you see as 2 raised 0 times 7 raised 0. Both of them are just ones. So if you multiply 25 by ones, you just get 25. What is the bigger exponent between that term and that term? It's 2. Bigger exponents between that and that is 7. So the final answer will be 350. You can easily verify this. 350 is divisible by 25 as well as 70. So 240 and 285. See, I'm tempted to jump to 10 and 5 right away, but since we are sticking to a process 2 and 120, which is 240. 2 times 60, 120. 2 times 30 is 60. 2 times 15 is 30. 2 doesn't divide 15, so 3 times 5. $285. I'm going to start with 2. Well, does 2 divide 285? No, it doesn't. Let's check 3. 8 plus 5 is 13. 13 plus 2 is 15. Sum of the digits is divisible by 3. So it is divisible by 3. So it's 95. Is 95 divisible by 2? No. Is it divisible by 3? No. 4? No. 5? Yes. So we end up having the factors as 240 is 2 raised 4 times 3 times 5. 285, 3 times 5 times, oh, I meant to write 19, not 9. So 19. What is common? Well, I've got 3, 3, 5, 5, 19. Mind you, we can't just ditch that 2 raised 4 because we are finding the common multiple. So in this case, it is 2 raised 4 times 3 times 5 times 19, which would be 4,560.